Hello, I'm William Deljudas, and I go to Kearsarge Regional High School. I'm going to be making a game through Unity for my senior project, but also as a resource to others using Unity for game development. My goal is to build a survival-type game similar to Rust, where the player fights off monsters. It's going to be solo player, and the world is going to be procedurally generated. I won't share all the code because I am going to publish it on Steam at the end, and potentially on mobile as well, but I will talk about the important aspects and share code snippets that I feel are especially essential to the game. So let's get into it. So I wanted to make this video early on so I can show you guys where I started from, and so currently right now, all I really have is a chunk loading scheme that renders the terrain around the player. And so if I hop in here, um, you can see basically just the chunks floating around the player. And the two first things you'll notice is one that, well, my view distance is very low, but one thing you'll notice is that the chunks actually have a height to them. So as you can see, this chunk is, the top chunk above it is not loaded in, but when I come up here, it loads that top chunk in. And I want to do that because I want to eventually create very, very intricate underground caves. And if I make this system of 3D chunks, unlike a game like Minecraft where the chunks are actually infinite in the vertical direction, I could technically have an infinite underground world just as far, so you could travel just as far down as you could left or right. And I think that'd be a cool feature that I don't think I've really seen in any other games. And the other thing you'll notice right away is that it's very triangulated, so it looks very low poly. And um, I haven't settled on that decision right now, but for right now, the reason why it looks like that is because I'm actually using the marching cubes algorithm. So this is procedurally generated, and right now I'm just using 2D Perlin noise to generate the height values for the isometric quantities. But um, what I'm essentially going to introduce is 3D Perlin noise, and so the way that it randomly generates this is, you might see in other procedurally generated mesh videos where it just basically makes a flat grid of a mesh and then raises all the points by some value, but this is actually using the marching cubes algorithm, which computes in like an isometric space and basically just tries to create a mesh that surrounds all those points. And it's a little complicated, but I could make a video on it demonstrating how you would do it in code, and I actually used a compute shader to write it. And there's a lot of great tutorials out there, but I will say that I found most of them don't go into the code in depth as much as I'd like them to, and it took me a lot of trial and error to get this. But that's why it looks like this. And so it's kind of weird to think that this is actually a voxel mesh. And so if you don't know what voxels are blocks, and that's basically like what Minecraft is. And you think, well, this doesn't look anything like Minecraft, but they actually have the same underlying principles and the same underlying data structure for how the worlds are set up. The Marching Cubes algorithm just blends these meshes together. And so I have a couple things still on the table for me. One of them is going to be potentially running a compute shader to smooth out the vertice normals, which if you don't know what vertice normals are, they determine how light is calculated, and that's why you can see all these triangles very clearly, is because if you look at it, these are actually all the same color, which isn't too hard to tell. I mean, they look like the same shade, except they just have different levels of lighting, and that's because I have a fixed light up there, and that's why this whole mountain looks black currently. But if I actually had a UV normals map on this, and I actually blended the triangles in with their vertexes, you would see this looking very smooth. And I'm thinking of writing a compute shader to fix that, because beforehand I had this just written in raw C# in my game object, and it was slow. It was incredibly slow. I mean, I was probably taking about 1 or 2 seconds just to cross a chunk border, which, as you can see now, it's virtually instant as soon as I crossed a chunk border. But the other thing that I have to put into a shader is I'm going to also compute the colors. So obviously right now it's one color, and I don't want it to be finalized with one color, obviously. So I'm going to just basically add another data point to each space. So right now each space has 4 points to it. It has the 3 x, y, z coordinates of the points, like take this point right here, and then the 4th point is its isometric value, and so that just determines whether or not it gets rendered in the space. And so basically, like I said, what the margin cubes algorithm tries to do is it tries to just wrap all the isometric quantities that are above a certain threshold in a mesh procedurally. And so I also have to add a 4th point that'll sort of be like the points type. And so you can think of Minecraft like it's like a block type. It could be a dirt block, a grass block, and so I want to add different types so that I can make stone, or maybe different types of stone, different types of dirts, and I think that's an important thing, and that'll determine the vertex colors. And so then the other shader I'm gonna have to write a compute shader that'll generate the noise a little better. So right now my noise is obviously, like I said, 2D Perlin noise, which this is actually in a particularly bad case of it, but it looks a little repetitive, and it doesn't have any very defining and unique terrain structures such as caves or overhangs. You can see that it all just looks like a variation of a mountain peak. And so if I add some 3D Perlin noise, which is essentially just some computations onto a 2D Perlin noise, then I can generate unique, overhangs, and I can generate some cool cave systems, and hopefully infinite caves, and that'll be really cool. And I'm also going to look into some other noise functions like fractal noise or simplex noise to make just like some really unique structures, as well as maybe biomasks. And I want to kind of go all out with the procedurally generated terrain here, because it's not that complicated to find functions online that people have written and to just implement them into my compute shaders. And it'll obviously take no time in runtime, because the compute shaders are incredibly fast, and it's such a small step that can make this game look so much better in the form of terrain. The other big thing I wanted to go all on the terrain generation for was because I don't want to actually generate a lot of chunks. Obviously, like in a game developer's interest, it would be to put the least stress on the computer so that I could free up more space for intricate things like just vertex shaders for making like cool tree effects and stuff like that. But so to not generate the most chunks, I either need to make the game look crappy like it does now, where you can see into the abyss, or I need to fill up the player's view. And so if I generate some very like hilly, very weird looking terrain like I am right here, then not only will it feel like such a unique environment that the player's never experienced before, but it'll make it so that the player won't be able to see that far into the distance, and then I can essentially not generate that many chunks, and I might make some sort of additional compute shader that sort of calculates the volume of an isometric, if you take the isometric quantities and like basically just sum all of them, then you can kind of get a rough estimate of how filled that chunk is. And then, if the chunk is very filled, I just don't have to generate a chunk behind it, because the player can't see that. And then the other unique property I'm going to add for my chunk rendering is because I have Y level chunks, so I have chunks above and below me, which, like I said, can allow for infinite travel in the Y direction. Because I have that value, I'm going to need to generate chunks, load chunks above and below me. And so the way I'm thinking of doing that is basically just computing the isometric values at the Y1 level of the chunk I'm rendering, and if there's any holes in that chunk, so if any of the values are below my isometric cutoff value, then I'm simply going to trigger a chunk update on the chunk with the coordinates of, the same coordinates, but just -1 in the Y direction. And so, speaking of the chunk update script, basically what I have right now is a static class, or a non-static class with a couple static functions that sort of manipulate the entire chunk list. And so I'm basically using some static functions as the chunk manager for my chunk class, and this makes it a lot more simple because I don't have to create a chunk manager game object and then create a bunch of chunk prefabs. And right now I just have a chunk prefab, and that has a chunk script on it, which sort of manipulates the entire chunk with a bunch of static static functions that update all the chunks. And I have it set up. I think I have it set up pretty nicely, because basically I have a chunk dictionary, which the keys are all vertex 3 ints, which are just the chunk position, and then of course the values are the chunks themselves. And if you don't know what a dictionary is, it's basically just a way to look up data values. So it's really handy, especially for something like this, where I wouldn't want to loop through every chunk and see if it has the same coordinates as the one I want to update, because that would take a long time. But instead I can use this key value pair. And then so when you get to a chunk, when you trigger a chunk update, it'll actually have to go through 3 separate processes. The first process is obviously to try that dictionary and see if this chunk is loaded. And so yeah, right now these are all loaded chunks, and so this is very unideal. I definitely have to unload some of those chunks in the distance there, but it would basically be looking through this dictionary. Then, if it didn't find it, it would look through a separate list of game files. And so I'm thinking of basically generating game files from chunks with a sort of unique name that'll have the chunk ID or the chunk position in the name, so that I can easily just check if, say chunk underscore 1 underscore 2 underscore 1, which would be like the chunk at 1 comma 2 comma 1. I can chunk if that file name exists, and then if it does, just grab that chunk and load it as in that position. And so I think that'll be a really cool way to basically dictionary my chunk files and save a large amount of time on processing power. And then, the third option is, if the chunk does not exist in the files, then it's going to just have to obviously regenerate it or generate from scratch. And the other process I kind of want to am interested in using is chunk recycling, which I saw a couple other people do on some videos, where they make a queue object, which is, you think of it like a dictionary or a list, any of those sort of complex data structures, and then I can basically reuse the chunk prefab object and just fill it with, the new space, the new mobs in the chunk, or other, vegetation or stuff like that in the chunk, and then I can sort of reuse that object. That way I don't have to delete and recreate, which will be obviously pretty taxing on the stack. And the other thing that I really have to get done is I have to do vertex colors. So as you can see right now, the map is all very bland, and that's not only because I have nothing else in it, but also because the colors are all the same. And so I'm not sure yet whether I'm going to write a new compute shader, which, if you can't tell already, I love them. I just started learning them, and they're just such a lifesaver, just so good for computation and for saving processing power. But I might actually just incorporate the vertex colors in with the existing shader. And so if you don't know what vertex colors are, basically I can shade the color at any point in space, and that'll kind of, if, given 3 vertexes of some shape, it'll interpolate those values and create a color for this triangle. And so I'm gonna have a little bit of an issue here, because actually in reality the points of the space lie inside these triangles. So for example, this triangle right here, these 4 faces, actually that might be 5 faces, are all being generated in part by the point that lies in the center of these. And so it's going to be a little interesting how I do that, because if I set my type of object here as, like, say, rock, and this color is gray, then it potentially can affect all these triangles around it, when I only want it to be this small rock. And so I'm going to have issues with that. I'm going to have to figure out how I can best sort of interpolate these values to get maybe grass down here, which fades into rock. And if I can control that interpolation, that'd be pretty nice, and that'll increase my generation, because in other games the triangles are like solid colors, and if I can avoid that, that would make it look a lot more smooth, and it would make it feel like even more random and even more generated. But I don't think it's the end of the world if I can't avoid that. It's just something to keep in mind. So that'll also be a compute shader. And after I get all this sort of color stuff done and the terrain stuff done, I can't wait to move on. And I'm going to be, like I said, moving on to monsters, which I have an interesting idea for those that I don't want to share too much, but it's going to involve inverse kinematics and some procedural generation. I love procedural generation. I can't wait to use it in pretty much everything. But yeah, it's going to be exciting. The other thing is I get to also make some static objects, like trees maybe, or other vegetation. And yeah, that's where I'm at right now. So I'm probably going to get to work on the shaders. So I'll see you guys in the next video. Bye.